So the complete GD&T for this drawing is done. Now let's understand the significance of these symbols. So first I'll switch off the snap lines and I will maximize it. So to understand GD&T as a design engineer, we must understand the functional areas of the part. And if you see this part, you can easily understand that this area is critical in this part, this thread is critical in this part, this outer cylindrical surface is critical in this part, this feature, this inner cylindrical feature is critical in this part, and this feature is critical in this part. Now based on our understanding and the function of part, we start GD&T by assigning datums. Now how datums are decided, that I have already explained in my previous video. So let's understand once again. Now this part is having three datums, datum A, datum B and datum C. Now these datums are decided based on the function of the part and based on the fixing of three directional movement of the part. So when this part is manufactured and it came for inspection, the first thing we do is we place this part onto our inspection table. So we either place using this surface or this surface, and that is why we can either assign datum A for this surface or this surface. So in this case, I have assigned datum A for this surface because I am placing this surface to my inspection table. So let's understand that this line is your inspection table. So you are placing this part to this table using this surface. So the moment you place this part onto this surface, this directional movement is blocked. So one directional movement is fixed. Now this part can move either in this direction or in this direction. And that is why we assign the primary datum, datum A, to that surface. Now this part can move either in this direction or this direction. So now if we fix this center axis, then automatically these two directions will also be blocked, and that is how we select datum B to this center axis. Now the datum B is this center axis, which is for this particular cylindrical feature from here till here, and datum C is for this particular feature from here till here, this center axis. Now when we decide this surface as my primary datum, we immediately put flatness to that surface because everything will be referenced to the primary datum. That means everything will be referenced to this surface. So this surface has to be the best surface in this part, and that is why we assigned the flatness. Now the next symbol is this symbol, parallelism. Now since we was not able to place this part using this surface onto our inspection table, we didn't apply datum A to this surface. Otherwise, I would have applied datum A and flatness to this surface to avoid this symbol. So in such cases where you cannot apply your primary datum to the critical surface, but you need this surface to be treated just like the primary surface, you apply parallelism. So now we are telling that this surface should be parallel with this surface. So if this surface tilt, this should also tilt. That means this surface should exactly reflect like this surface within this given range, and that is why it is referenced with datum A. Now the next symbol is this symbol, which is again referenced with datum A. So now this symbol is attached with this dimension. That means this symbol is attached with the center of this dimension, which is this center, the smaller center. So you are telling that this center axis should be perpendicular with reference of this surface. That means this center axis should be exactly 90 degree with reference of this surface. So if this surface tilt with some angle, this axis should also tilt within this given range, and that is why it is referenced with datum A. And parallelly you have assigned datum C to this center axis. Now the next symbol is this symbol, which is again referenced with datum A and datum C. So now this is run out. Now again this symbol is attached with this dimension. That means this symbol is talking about the center axis of this feature. So it is telling that the run out should be within this range with reference of datum A and datum C. Now what is run out? So run out is actually combination of straightness with circularity, and you are telling that the axial out with reference of A and C, that means this axis axial out with reference of this axis should be within this range. Now to understand this, I have another example. So this is the example. Now you see, this is the car axle design. Now this is the axle where the entire load of the car comes, but the wheel is attached somewhere here and here. So there are two center axes. This is one center axis and this is one center axis. Now this value is 0.05. So this is the axial out from this axis to this axis out. Now you are telling that this axis should be concentric and straight within that range, within 0.05. So here you are telling that this axis can be actually out with reference of this axis within this range. So now one thing you will notice that everything is controlled by this datum A, this surface. If this surface tilt, this axis will deviate. If this axis deviate, this axis will also deviate. Now the next symbol is this symbol. This is also run out with reference of B. Now to understand this run out, you have this feature. So this feature is having separate center axis somewhere here, the smaller center axis. So now deviation of this center axis is reference with B. So if this B center axis is deviating from here, then this should also deviate according to this center axis. Similarly, this symbol, the position of this center axis, is again reference with datum B. So deviation should be within this tolerance range. Now coming to this symbol, again position tolerance given here. Now if you see these two dimensions are the basic dimensions, and general tolerance is not applied to the basic dimension. That means these dimensions are having a separate tolerance given in the drawing. Now where that tolerance is given? So if you see this dimension is given for this pitch circle, this center axis. And if you see this dimension, this is also given to this center axis. So these two dimensions are given for the center axis, and now this symbol is attached with this dimension. That means this symbol is for the axis of this dimension, so which is this axis. So this symbol is attached to this axis, and these dimensions are also attached with this center axis. So the tolerance given with this symbol is the tolerance for these two dimensions. So it is referenced with datum A because datum A is the primary datum, and this part is placed using the primary datum on the inspection table, and datum C is the smallest axis somewhere here. So the deviation is happening based on this smallest center axis somewhere here. So if this center axis move here and there within this tolerance zone, then this pitch circle and this axis will also move. So this was the significance of these symbols. Now you can like this video if you find this video helpful, and I'll see you in my next video. Thank you.